today's lesson. Today we will apply basic factoring to polynomials. We will be able to explain how we factor completely. So let's take a look at today's lesson. Let's take a look at today's do now. We want to answer the following and we want to simplify each. So when they ask me this question, all they're asking me to do is just distribute. So I'm going to let you guys pause this video and we will get back together once you are done. So for number 1, when I distribute the 2, we should get a 2x plus 8. For number 2, when I distribute that 2x, we get 2x cubed minus 6x squared. You must remember how to apply your laws of exponents for number 2. Thinking for today, what does it mean to factor? Factoring skills. Factor means to rewrite an algebraic expression as an equivalent product. We will need to undistribute the algebraic expression. Factoring process. The first thing you have to identify is a greatest common factor. So identify the greatest common factor by looking at each term and seeing what we can divide all terms by. If you don't have a greatest common factor, then you might have number 2, the difference of two perfect squares. So what are perfect squares? 1, 4, 9, 16, 25, and so forth. If you have a difference of two perfect squares, then that is the type of factoring we have. If that is not the case, then we might have a basic trinomial factoring when the a value is 1 or the first leading coefficient is 1. And then we have the more advanced one, which is trinomial factoring, but when a does not equal 1, which is what we are going to focus in tomorrow's lesson. So first thing that we need to do is make sure that our problem, if we only have one variable, is written in standard form. So normally we have a quadratic, and our standard form would be ax squared, again the highest exponent first, plus bx plus c. We want to start with the highest exponent and write it in decreasing form when we have one variable. If we have multiple variables, we normally won't write it in standard form. So let's look at example number 1. For example number 1, we want to factor each below. So I have to make sure I have my problem written in standard form, which I do. The next thing I am going to determine is, do I have a GCF? That is the first question I ask myself when they ask me to factor. Can I divide both these terms by a common factor? And my answer is yes. My GCF here would be a value of 2. So what do you do with the GCF? You take it out and you divide each term by 2. So if I divide the first term, 2x squared by 2, we get a 1x squared. If I divide positive 4 by 2, we get a positive 2. And that is it. I can't keep going. For number 2, same kind of process. Is this written in standard form? Yes. Can I divide both these terms by a common factor? And again, my answer is yes. I can take out a GCF of 2x. So when I take out that GCF, I divide each term by that GCF, giving us 2x times 3x minus 5. For number 3, is this problem written in standard form? No. So we must write it in standard form first before I start determining if there's a common factor. So now that it's written in standard form, can I divide each of these terms by a GCF? So my GCF for number 3 is 3x. I divide each of these terms by that 3x. That GCF comes in front and I am left inside the parentheses with 5x squared plus 6. So don't forget, when we are factoring, what am I doing? I am undistributing. So if I were to distribute back that 3x, I should get back the original problem. For number 4, now this one here has 2 variables. So I am not going to rearrange it in any form. What I am going to do is determine if there is a common factor, a greatest common factor. So I can take out a 2 or divide each of these terms by 2, but I could also divide each of these terms by x and y. So my GCF here is 2xy. So just like before, we're going to pull that GCF in front, and we are left with x plus 2, and that is all. For number 3, I am not going to rearrange this. I have multiple variables. I'm leaving it alone. I am going to determine what can I divide both these terms by so I can pull out a GCF. So as far as the numbers go, I can divide each of them by 7. I can divide each of them by x, and I can divide each of them by y squared. So my GCF is 7xy squared. What do I do with that GCF? That GCF comes in front of my parentheses, and I divide each of these, giving me 2x minus 3y. The last one here, again, I am not rearranging anything. I am leaving it alone. I am focusing on each of these terms. What can I divide each of these terms by? So my GCF here is 3x squared y. I take that GCF in front, and I am left with 4y to the second z plus 5. The x squared in the second term and the y both canceled out. So that is our GCF factoring. Let's look at example 2. For example 2, we want to factor completely. So for factoring completely, we must go down the process. We're going to start always with, is my problem written in standard form? Next thing, is there a GCF? If there is, I take it out, I divide each term by that GCF. If there is no GCF, do I have a trinomial that I must factor? Is this a basic trinomial, or is it a more advanced one? Example number 2, factoring completely, we want to do number 1, factor x squared minus 16. So here I have a difference. Minus means difference. I have x squared, which is a perfect square, and I have 16, which is a perfect square. So this is a difference of 2 perfect squares. So how do you factor the difference of 2 perfect squares? We got x times x would give me that x squared. Positive 4 and negative 4 would give me that 16. And that's all. I can't keep going. For number 2, first thing is this written in standard form? No, so I must rearrange the order. So I have it now written in standard form. The next thing I'm going to ask myself is there a greatest common factor? And obviously my answer is no. The next thing I'm going to determine is, okay, this is a trinomial. I have 3 terms. That means that we are looking for 2 numbers that multiply to the last, and those same 2 numbers have to add to the middle term. So this is known as the AM method of factoring. Some teachers refer to it as that. This is just a basic trinomial factoring. So if you know your factors, awesome. But if you do not, you can use your calculator to give you a list of factors. And how do you do that? You're going to go to y equals, and you're going to input the multiplied piece. So I want 2 numbers that multiply to negative 27. So I'm going to input that value in there and divide this by x. What the calculator does is it gives me all the factors that multiply to negative 27. So I'm going to press second graph, and here are all my factors. I do not care about those decimal values. But I also need to pay attention to what I wanted to add to. I wanted to add to a positive 6. So I'm looking in my list and which two integers add up to a positive 6. So when x is equal to 9, y is equal to negative 3. If I add up 9 with negative 3, I get a positive 6. So these are my two factors right here. So how do I factor this? So n squared, we factor as n times n. And I did find my factors, positive 9 and negative 3. You must always make sure that the two numbers you're choosing multiply to negative 27, which is the last term. And those same two numbers, when you add them, add up to a positive 6. So kind of doing a quick check on the side, but if I'm using my calculator, that is what I am doing anyway. So this is our basic trinomial factoring. All right, let's look at number 3. So first thing is we want to rearrange this. Next thing is there a GCF? So there is a GCF in this problem. The GCF is 5x. So I'm going to do what we did before, right? We take out that GCF and we divide each term and we end up at 4x squared minus 9 inside the parentheses. Now I am focused inside the parentheses. Can I keep going? So I can. This is a difference of two perfect squares. Again, there's a difference in there. So 4x squared can be broken up as 2x and 2x. 9 can be broken up as positive 3 and negative 3. And I must always remember to take that GCF and write it in front. So this would be us factoring completely. Factoring completely normally means that you will take multiple steps to factor. So let's look at number 4. Rearrange your terms first. Is there a GCF? There is. So we are going to take that GCF out. Look inside the parentheses. You have a trinomial. So this is basic trinomial factoring. We're looking for two numbers that multiply to positive 12, add up to a negative 7. Again, you could put this into your calculator. Y equals positive 12 divided by x, second table, gives me my list of factors. I want a negative, so I'm looking at the negative side. Negative 4, negative 3 would be my two factors. That GCF has to come in front, always. Do not forget about it when you had a GCF. All right, let's look at number 5. Rearrange your terms. Take out the GCF if possible. Look at what you have left inside the parentheses. Can you keep going? And in this case, yes, we can, so you must. All right, last one. We have 81x to the 4th minus 16. So here we do have a difference of perfect squares. Anytime you have a higher exponent and it's even, that means that you can factor this. So I'm going to break 81 up as 9 and 9. I'm going to break up x to the 4th as x to the 2nd, x to the 2nd. So that would be our first term. Since we have a difference, that means 1 is plus, 1 is minus, and we have 4, and 4 will give us that 16. Now, pay attention to this second piece here. You have another difference of perfect squares. So I'm going to rewrite that first piece down, and I'm going to expand that highlighted piece. So 9x squared can be broken up as 3x times 3x. We have a positive 2 and a minus 2. And this would be us factoring completely for number 6. Example number 3. So now that we looked at all the factoring processes, we can actually apply solving by factoring. So for number one, they want us to solve. First thing I want to always make sure is this written in standard form? Yes. I always want it to be equal to 0, which I already have. So I'm just focused at the beginning piece, and I'm going to factor this as I did the previous ones. Is there a GCF? Take out that GCF. What do you have left behind? So this would be us factoring. But this is an equation, so I must say equal to 0. So just like before, now I'm focused here. Can I keep going? Can I keep factoring this? And my answer is yes, I can keep factoring it. So I'm factoring that trinomial, not forgetting about that GCF, and setting this equal to 0 because it is an equation. Now, what we are going to do is we're going to split up each of these pieces. So we have a split here. And I'm going to set each of these equal to 0. This is known as the zero product. The zero product tells me that I could determine or set each factor equal to 0. So if I do that for that first piece, the 2x equals 0, I could divide each side by 2, giving us x equals to 0. There's one possible answer. If I solve for x in the second one, I would minus 8 on both sides. And I would get x is equal to negative 8. This is another possible answer. And the last one, I would minus 1 from each side and get x equals to negative 1 as our third possible answer. So in order for us to know whether we did this correctly, I am looking at the highest exponent, which is 3. That tells me how many answers I should have. I should have 3 answers, which I do. I have an answer of 0, an answer of negative 8, and an answer of negative 1. Let's look at number 2. So we want to solve this. In order for us to solve this, we want to have your equation equal to 0. Why? Because I see an exponent. Anytime I see a higher exponent, not just an x squared, x cubed, x to the fourth, any higher exponent, I set this equal to 0. I must make sure I write my answer in standard form as well. So I did that. Now what we are going to do is we're going to factor this. So I see there's a GCF of 2. I'm taking it out. This is an equation, so don't forget to equal 0. I am focused inside the parentheses. Can I keep going? And I can, so I factored it using the trinomial method. I am going to split each piece and set each equal to 0. And I'm going to solve. So for this first piece, I have 2 is equal to 0. Now that does not make sense. 2 is never equal to 0, so I'm going to slash that. That is not a possible answer. But that answer must be on paper because that was part of my GCF. For the second piece here, we have x is equal to negative 8. For the last piece, we have x is equal to negative 1. So how many possible answers do I have? I have 2. And I should know that I did this correct because my highest exponent was 2, which means I will only see 2 possible answers. In the previous one, my highest exponent was a 3, therefore I should see 3 possible answers. And that is it for today. So keep learning, keep growing, and I will see you in our next video.